Here we have problems number 68 and 69, and so this brings up an interesting question, right? We have limit of x minus 1 as x approaches 3 from the right hand side and as x approaches 3 from the left hand side. So looking at this, we know that x minus 1 is a linear function, right? So we know that y is equal to x minus 1. This is a linear function, and whenever we're talking about these quadratic functions, cubic functions, linear functions, chordic functions, we have to understand the concept that these are continuous, right? You could have a piecewise function or anything else, and you may have a break or something like that, and then you see these discontinuities emerging, right? Especially for rational functions when we have these asymptotes, right? But usually when we're talking about a linear function or any type of polynomial, right, we must understand the concept of continuity, right? That the function is continuous, and so same thing with x minus 1, right? That's just a line. When we graph this, it's a line. So if I do just give you a visual representation of this, we know x-intercept, the value of x when y is set to 0, that's 1, 1, 0, right? So this would be 1, comma 0. And then we have the y-intercept value of y when x is set to 0, right? That would be, so we get negative 1 here, so 0, comma negative 1. So we can plot this and we would have something like this, right? And it's ongoing. Now this question here states that the limit of this function as x approaches 3 from the positive side. So it's not a hard question at all, right? Because if you think about it, you approaching 3 from the right hand side, right? And then you have 3 approaching from the left hand side. It doesn't really matter because here we don't have any discontinuities that are present, right? When we're saying that it's approaching 3 from the right hand side, what we're really saying is that it's actually approaching 3, right? It's actually getting to the value of 3 because there is no discontinuity. There's no discontinuity present at the point x is equal to 3, right? So really what we're doing here is substituting, right? We're using substitution here because whenever you have a continuous function and you're looking at the concept of limits, you can really you can evaluate these questions here by just substituting your value directly, right? Because if you think about it, at 3 you would have something like 3 comma 2 here, right? 3 comma 2. And so as you approach this value of x, right, which is 3 in this case, from the right hand side and from the left hand side, you should understand that you're approaching the value 2, right? The y value of 2, and which is the same thing as just simply putting 3 in for x. So this would be 2, this would be 2. And clearly you see that the one-sided limits obviously are equal, therefore you could say that the limit of this function as x approaches 3 obviously does exist, and it is indeed 2, right? And really what I wanted to show here is you don't have to make problems complicated dealing with limits, right? If you have a continuous function, you're just directly utilizing the method of substitution to determine your value. So for question numbers 68 and 69, your answer should be 2. So thanks for watching.